This is Dr. Olson for Meteorology 2010 at Daytona State College. This is the third and final video for Chapter 1 on the Earth's atmosphere. In Part 1, we talked about the origin of the atmosphere. In Part 2, we talked about the structure of the Earth's atmosphere. And now in this final portion, we are going to be talking about the difference between weather and climate. We often use these terms interchangeably, but there is a very significant and important difference. What is the difference between them? Well, weather is a term for immediate measurements, a short-term type of measurement. For instance, what is the temperature right now? What is the pressure right now? What is the current humidity? What do the clouds look like? And so on. If you can say right now, then we're talking weather. On the other hand, climate is a long-term pattern. In other words, it's an average weather over a long period of time. Since we're talking about weather over a period of time, we need to talk about not just a number or a magnitude, but we also have to talk about a frequency. How often does it happen? So for instance, we say summers here in Florida have an average temperature of around 85 degrees, just throwing out a number there, and an average humidity of 95%. We're talking average, so over a long period of time, lots of measurements, it's an average. But notice I said summers in Florida. That means frequency. Every summer it gets to be about that average number. Another way to talk about frequency is in the summers are hot and humid, but winters are cooler and drier. There's a frequency pattern there, just showing how often the long-term weather patterns change in Florida. So that would be a climate statement. And along with weather versus climate, we need to also talk about weather observations. How do we get data? How do we know what the current weather is so that over a long period of time we can also find out climate? Well, there are lots of different ways to make observations. First of all, satellites have become one of the most useful tools that we have for weather observations. We use what we call geostationary satellites. Now, geostationary means holding still in the Earth's orbit. Geo meaning Earth, stationary meaning holding still. So basically you pick a point up in the sky and the satellite appears to us on Earth as if it is holding still. So it's remaining above that single point. Now, what's the advantage to this? Well, there are lots of advantages to this. First of all, one of the main advantages is you are taking pictures of the same view every time. If you took a view from one side of a mountain at one point of a day, and then from the other side of the mountain from the other point of the day, you're going to have two completely different views, and you can't really compare the two because you're looking at different things. But if you have one camera focusing on the same view of the mountain day and night, you can compare them. So we do the same thing with geostationary satellites. Have one view of the Earth and just watch the cloud patterns, and then we can get a better idea of what's happening with the weather using these geostationary satellites. So with this, we need a way to measure all of our data from satellites. So we use meridians, which are measures of longitude, as well as parallels, which measure latitude. So longitude measures how far east or west we are, and then latitude's north or south of the equator. Those terms are not new. I am sure everyone has seen them. If they are unfamiliar to you, please let me know, and I would be happy to explain them a little more. Now, there are three, longitudes really don't have that much of an effect on weather, unless you're talking about water versus land, but that is a topic for another chapter. But right now, the biggest variation in weather is variations in latitude. In other words, closer to the equator are hotter temperatures, closer to the poles are colder temperatures, which I think goes without saying. So we separate the Earth into three regions. We have the tropics, which are any latitudes between 23.5 degrees north and 23.5 degrees south. We have polar latitudes, which are any latitudes beyond 66.5 degrees north or south. And then you have middle latitudes, which is anything between 23.5 and 66.5 degrees. You'll hear these three terms, tropics, middle latitudes, and polar latitudes, quite often in this chapter, or in this course, excuse me. So be familiar with those. Now this number 23.5 degrees, we have always been taught that that's a constant number, but believe it or not, it's actually not a constant number. Here's a picture of a highway in Mexico with a bunch of signs marking where the Tropic of Cancer is located from 2005 through 2010. Now, I actually looked this up on a map, and we are looking, I believe, to the north, if I remember right. So, looking to the north means that the latitude of the Tropic of Cancer is actually moving northward from year to year. That has to do with the fact that the Earth is tilted at 23.5 degrees, but really the Earth's axis is wobbling a little bit, which will come up again later in the course as well. There's one more point I have to go back here. With all of the data we have from our stationary satellites as well as land-based stations, we can use that information to determine locations of any weather events such as pressure cells, fronts, surface stations. We can use all of that information to determine and forecast the weather. Now, here's how useful satellites can be. Here is a picture of the Earth. And you can see a handful of big events. For instance, down here in the lower left, there's a hurricane that you can see right away. A bunch of isolated clouds. These are just thunderstorms. But then you see more solid features. For instance, here's a cloud that seems pretty constant and almost has this hook shape. Well, all we have to do is see that on a satellite and we can tell right away that we have what's called a mid-latitude storm. And so we can associate certain fronts with it. So we take what we see on the satellite and we translate that to a map, which is what we use to describe weather on a TV station. This figure is in your book. Here are some very key symbols that are very important for the course that you should know. There are others as well, which is the next and final thing that we talk about in this video, our weather symbols. Once we have weather data, what do we do with it? How do we show it out to the public? This information, by the way, is covered in Lab 2. So this is where you will be seeing it here in the near future. When a station has data, there is a way to very quickly compile all of the data and display it in one quick picture. Here you see a little circle. This is the location of a station. And then how full the circle is will tell you the cloud cover. So if it's an open circle, so you can see on the right here, it's clear. And the more full that the circle is, the more overcast the sky is. So here in this figure, this station is overcast. And then from that circle, you see a little flag. This flag is indicating the direction the wind is coming from. So in this case, wind is coming from the northwest to the southeast. So we say it's a northwest wind. And then here are these flags indicate the wind speed. I'll show that to you in the next slide. When you have a short barb, that means 5 knots. I'll explain, well, I can tell you now. A knot is a term from the naval era. It's just a way of measuring speed in naval terms. And it turns out that 1 knot is about 1.1 miles per hour, just as a reference. So 1 short barb indicates 5 knots, 1 long barb indicates 10 knots. So when you have a long and a short together, you have one that represents 10, one that represents 5, add them together, you get 15. And so on, that pattern continues. Here you'd have 4 long barbs and 1 short one, so that would be 4 tens, 40, and a short one, 5, 45 knots. The other numbers in this station indicate other measurements. For instance, the top left number will indicate temperature in Fahrenheit. The bottom left indicates what we call the dew point, which will be covered in Chapter 4. The top right number indicates pressure, and the bottom right number indicates pressure tendency. Is it rising? Is it falling? And how much is it falling or rising? Now, you can't just read this as 138. We need to decode this. The way we do that is we put a decimal before the final number. So this would be 13.8. And then in front of the number, add either a 9 or a 10. Whichever one would bring us closer to 1,000, that would be it. So in other words, we could have either 913.8 or 1013.8. In this case, 1013.8 is closer to 1,000, so that is the correct answer, 1013.8. Then down here is our pressure tendency. Plus means that the pressure is rising. Put a decimal in between the two numbers. So it's rising at a rate of 2.2 millibars in the past 3 hours. 2.2 millibars in 3 hours. And that's how you read those weather station plots. This will be the topic of Lab 2, as I said earlier, so you'll be able to go through everything I just said once again. And that concludes Chapter 1 on the Earth's atmosphere. Should you have any questions, please feel free to call me or email me. I'd be happy to answer whatever I can as soon as possible. Thank you and have a wonderful evening.